All right, good morning, everybody.
Good morning, Miss Clinton.
All right, so today we're going to go back over our commutative properties of multiplication. So let's look at our learning intention and success criteria for today. Our learning intention says multiply factors
in any order.
And your success criteria,
I can use arrays to show the commutative property of multiplication. I can write two multiplication equations for any array. I can use the commutative property of multiplication.
All right, so our learning intention says to multiply factors in any order. Now, what are factors? When we look at our multiplication equation right here, we have 2 times 4 equals 8. Where we see that number 2 and that number 4, those are our factors. And that number 8, we know from our keywords under multiplication, that is our product. Any answer you get when you multiply 2 factors becomes our product. So what are our factors? If I had 3 times 4 equals 12, what would be my factors in that equation? Ronald?
3 and 4.
3 and 4. All right, so our success criteria asks us to use arrays to show the commutative property of multiplication. And the commutative property of multiplication means you can use these factors in any order and get the same product, get the same result or the same answer. It doesn't matter which order you write your factors in when writing your multiplication equation. And we're going to use that doing what we've done already, which was arrays, because we had arrays as one of our multiplication strategies from before. So we're going to use those arrays to see how we can multiply these factors in any order and get the same result. So I have on the board 2 times 4 equals 8. So I know that with my first number, that is my rows. That's telling me I have 2 rows of 4. So I'm going to write 2 right here. Rows of 4. Now, if I had to use an array to show that, and it's telling me rows of, I know that's what an array is made up of. An array is made up of rows and columns. So I'm going to make my 2 rows. One, 2, and I'm going to make my 4 columns. 2, 3, 4. Okay, so I just created my array to show 2 times 4 equals 8. Now, if I'm doing the commutative property of multiplication, that means I should be able to use these same factors to get the same result. So if I'm going to use my arrays, that means I could switch these numbers around, right?
4 times 2.
So then I can make my arrays, and instead of having 4 columns, that would become 4 rows. Of 2. So now I have 4 rows of 2. And my multiplication equation my factors are gonna change. So now I have 4 times 2 equals 8. I get the same product. I get the same result when I switch those two factors around. And I created my arrays to match. So let's work one together. Let's look at this array. What is this array telling us? Turn and talk to your partner, and I want you to tell me what this array is telling you. How many rows do I have? How many columns do I have? And what would my multiplication equation be for this array? Justice, you can talk to Chase. Messiah, you can talk to Chanel and Tayon. Alright, so let's come back together. Now I'm going to call on one group to see what they discuss. I want you to look at your paper or discuss among your group. We're going to think to see if we got the same answer. And if you received something different, or if you thought of something different, then you let us know. Peyton, can you tell us what your group discussed?
Our group discussed that there were 5 columns and 3 rows, and it equals up to 15.
Okay, so Peyton said that her group discussed that there were 5 columns and 3 rows with an answer of 15. Did anyone have anything different? Jason, would you like to share?
Yes, our group discussed it that it was 5 rows and 3 columns, which equals to 15.
Okay, so why is it 5 rows and not 5 columns?
Because if it was 5 columns, it was going to be 5 rows that way. But if it's 5 rows, it's going down, it's going up and down.
Are rows up and down vertically, or are rows going across horizontally?
Up
and down vertically.
Rows are
Horizontal.
rows are horizontal. Rows are horizontal. So how many rows do we have?
5.
5. How many columns do we have?
3.
What would my multiplication equation be? Messiah?
5 times 3.
5 times 3 equals? Chase? 15. Now on your sleeves, I want you to work with your partner. Can you give me the commutative property for this using this array? I want you to create an array and give me what the commutative property would be for this equation. So I want you to create your new array. Create your new array. I want you to tell me how many rows of you're gonna have for the second equation and what that second equation will be. So work with your partner. Chase, work with Justice. You're gonna create a new array. So one partner can create the array, the other partner can write the new equation.
Okay, we're gonna create the array.
How will your array change?
I'll create the array.
Your first equation is 5 times 3 equals 15. If we're going to use the commutative property of multiplication, what would your second equation be? How are you going to do that? By drawing an array. Your factors are 5 and 3. Your factors are 5 and 3. Your factors are 5 and 3. What would what would be your second equation for your commutative property of multiplication? How many rows would you have in your array? How many columns would you have in your array? We're gonna come back in 5, 4, 3, 2, 1. Let's come back. Sire, can you share with us what you discovered? How are you going to make a second array to show the commutative property of 5 times 3?
I did 3, 5.
Okay, how did you set your array up? How many rows did you have for your array? Pardon?
No,
How many rows?
3.
3 rows. And how many columns did you have?
5.
5. Alright, so you said you had 3 rows of 5. And what is your multiplication equation?
15.
Give me the full equation.
5. 3.
3.
5 equals
3 times 5 equals 15. Awesome. Did anyone have something different? So do we notice our factors remain the same? Our factors are still 3 and 5.
Yes.
It didn't matter the order that we placed them in our equation, we still had the same product. Now looking at these two figures, look at your arrays. What is different about your arrays? What do you notice that is different about your arrays, Chase?
It was like 3 rows,
Okay, so one had 3 rows.
And the one had 5 columns.
So one had 3 rows and 5 columns. So what was different from that and the other one? Ronald?
So what was different is that instead of it being 5 times 3, it's 3 times 5,
Mm-hmm.
and they both were switched in a different place because the 3 was up in the columns at first, up in 5 times 3, but
Mhm.
now the 3 is up in the rows and the 5 up in the columns.
So we switched our rows and columns.
Yeah.
According to our multiplication equation. But the factors still remain the same. If I had blank times 4 is equal to 5 times blank, what would my first one be? Now I know when it comes to the cumulative property of multiplication, our factors remain the same. No matter the order you put it in, you get the same result. So Messiah, what would my first blank be? What should that be times 4?
3.
Try again. Jason,
5.
5. Why 5?
Because you on the other one it says 5 times blank.
So what would that blank be?
It'll be 4.
4.
Oh.
5 times 4 is equal to 5.
4 times 5.
Yeah, I saw what it did. 5 times 4 is equal to 4 times 5. I'll give you another one.
Yes.
Peyton, looking at this equation on the board, can you tell me what my first blank would be? 3 times blank is equal to 7 times blank. How would I complete this equation?
It will be
3 times 7 is equal to
7 times
7 times 3.
That's
So if you know your 3 times table, you already know that answer for your 7 times table, right? Because it gives you the same result, the same product.
Oh.
Your last one.
she ain't even right, ain't she?
Sire,
Easy.
6 times blank is equal to 2 times blank. What are my factors?
6 times 2.
6 times 2 is equal to
And equals 14 times
6. Who can give me the product of that? What is 2 times 6?
Oh, Lord.
What is 2 times 6?
Oh.
JC on
12.
12. So they both would come up to 12. Alright, take your textbooks out. You can clear your sleeves. And take your textbooks out, page 25 and 26. You can use the color towels to help you with your textbooks if you have to build your arrays. So you can use your manipulatives. So we're gonna turn to page 25 and 26. Angel, Justice, Ronald, Messiah, Tyon, and Peyton. You can get your laptops out and we can do a game of Kahoot. Angel, Justice, Ronald, Messiah, Tyon, and Peyton. Your game pin is on the board.
25 and 6. 25 to 26.
Page 25 and 26 in the textbooks. Everyone else, you're gonna do Kahoot. Your game pin is on the board.
You said 25 and 26?
Yes, sir.
Okay.
As soon as you're finished with your textbook and you've checked your work over, you can join the Kahoot meeting. Justice and Peyton, you can come up and join me. Bring your marker. No! Alright. both of you are struggling a little bit when it comes to arrays. So I want you, okay, you're going to create an array of 4 times 3. And I want you to create that array of 4 times 3. And then you're going to create a property where you're going to switch your factors around. I'm going to create an array telling you how that's done. Let me see. Yes, an array is made up of rows and columns. Your rows go this way, your columns go this way, right? Your first number in your multiplication equation tells you the numbers that are going to go this way. Your second number tells you the numbers that are going to come down in your column. So your number is going to be
No, A of N.
So I want you to create an array of 2 times 5 words.
Come back.
And then I want you to put both on the first equation, 4 times 2 equals, and then tell me what for your second equation. Okay, so if you create an integer property using array, how would this array change to show integer property of multiplication? How would you change this when you're on you have 4 times 3, this is 3 times 4, this is get variable, you get bring more for justice as well. Because every time you go in, if this is going to change to 5 times 5. Remember, you're still using the same factors. So if this is what you did for your rules, how would your rules change? If you had a term so that's what
Who's a pageant?
Come on, baby.
Gotta go.
This is going to be 2 times 5. This is going to be what would your alternative factor be? What would your other equation be? So then you need to create another shell. Right now, and then so at the bottom, I want you to write 2 times 5 is equal to 5 times 2. Okay, can you use your property? gotta count this, cause it's not so big, it's kind of big. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 'cause in here, you only have 5 rows, 5 columns. So anyway, this first number is how many times you're going along with this. So then you should have 1, 2, 3, 4, 5. So whatever your first number is, that's exactly how you set it up. 1, 2, 3, 4. Your second number is 7. Let's finish 7. So it'll be 1, 2, 3, 4, 5, 6, 7.
Huh?
And then you fill it in.
65 and 6. I mean 25 and 2.
You can play one chase if you're finished. Your first number always should always set. So if this was a 3, 1, 2, 3. Always. If this was a B, always do it.
The board.
If this was a 4, if this was a 4, 1, 2, 3, 4. Adjust this, you can go to your computer. So I'm gonna give you another number. And you really want to get these numbers correct. Alright? Okay. So let's do human Here's the first one you want to do. Okay. And this one is just on. Oh, you already have one here, so go on. Awesome. And then you go. And then the other thing. Awesome. Now, this is where this is. This is the commercial property for this is where we already come in. So this right there equals 1 times 6. So let's draw the array for 1 times 6. If you're finished with your textbook, you may do your Kahoot game. If you're finished with both Kahoots, you can do your textbook, page 25. Make sure your headphones are in.
Don't put to do 2.
That's fine, you can do your textbook.